Today, I will demonstrate for the first question, which is how to perform agglomerative hierarchy clustering using the help population 2 dataset in RStudio. The objective of this analysis is to group 38 countries into 3 clusters based on 5 selected health indicators. First, I import the dataset into RStudio. This dataset contains information on 38 different countries, including several demographic, economic, and health-related variables. Once the dataset had been loaded successfully, I can view the data to ensure that all variables have been imported correctly. Next, we will use the formula DF, arrow data frame, to get all the information for the Excel into the console for us to get easy evaluation. Next, I will create the clustering matrix, which is DF bracket C equal to the one that formula that we need, which is death rate, health expand, life expectancy, female mortality, male mortality. Next step is we need to include the row names for the clustering matrix for them to cluster which one, and we key in the DF for the dollar country. Next part, we scale the matrix in scale clustering matrix, and onto the next step, D matrix equal to distinct scale matrix, comma, method, and we use in this task which is Ulysses. And then for the HC output, we key in HC last, D matrix, method equal to average, and cluster assignment equal to cut 3, HC output, K equal to 3. And then we use the DF dollar cluster and cluster assignment, and then GNI underscore summary into the aggregate GNI cluster data DF comma fund equal to mean. And then we will print the average GNI per cluster, and then they will show here cluster GNI equal to cluster 1 equal to what, cluster 2 equal to what, and cluster 3 equal to what. And for then we will plot the EC output for the data given, and then we will plot the output using the formula EC output CEX 0.7 hang -1 mean. The title is centrogram, average linkage 3 clusters. So they will show the visual beside, and for the last step, we will put in the formula, which is RECT HC last bracket EC output equal to K3 and border equal to red. So from the diagram, they will show the red mark here. After forming the 3 clusters, we can see the calculated average GNI per capita for each cluster using the aggregate bracket function. Although GNI per capita was not included as one of the clustering variables, comparing the average GNI allows us to better understand the economic characteristics of each cluster. For cluster 1, it has an average GNI per capita of $90,439.68, which is the highest among the 3 clusters. This suggests that the countries in cluster 1 are generally higher income economies. Based on the health variable used in the clustering process, these countries are likely to have relatively higher health expectancy, long life expectancy, and lower male and female mortality rates. Overall, the cluster represents countries with stronger economies, resources, and better health outcomes. For the next cluster, which is cluster 2, has an average GNI per capita of $392.50, which is the lowest among all 3 clusters. This indicates that the countries in this cluster are economically less developed. They are likely to have lower health expectancy, lower life expectancy, and higher mortality rates compared to the other clusters. The low average GNI reflects limited financial resources that may affect healthcare access and overall population health. For the last cluster, which is cluster 3, has an average GNI per capita of $1,106.67. Although this value is higher than cluster 2, it is still considerably lower than cluster 1. This suggests that the cluster 3 represents lower middle income countries. Their health indicators are expected to be better than those in cluster 2, but generally not as favorable as those in Cluster 1. Overall, the average GNI per capita differs substantially across the three clusters. Cluster 1 has the highest average GNI per capita at $19,439.68 followed by Cluster 3 with $1,106.67, while Cluster 2 has the lowest average GNI per capita at $392.50. Even though GNI per capita was not used to create the clusters, the results suggest a relationship between economic condition and health outcome. Countries with higher GNI per capita generally tend to have greater healthcare expenditure, longer life expectancy, and lower mortality rates, whereas countries with lower GNI per capita tend to experience poorer health outcomes. Okay, on to the next question.
First, I installed the required package, which are Pretzel, Factor Extra, and Cluster. These packages are needed for importing data, performing clustering, and visualizing the result. This step is only done once. Next, I load all the required libraries using the library function. This allows us to use the installed package for data analysis and visualization. Then I import the NAPA dataset using the read Excel function. I select the NAPA data file from my computer. This dataset contains 35 observations of houses. After importing the data, I use the view function to display the dataset. This helped me understand the structure and contents of the NAPA dataset. Next, I use the str function to check the structure of the dataset. This shows the data types of each variable such as a numeric or integer. Then I use the summary function to get descriptive statistics such as minimum, maximum, mean, and median for each variable in the dataset. Since k-means clustering is sensitive to different scales, I standardize the dataset using the scale function. This ensures all variables are on the same scale before clustering. I set the random seed to 1 using setSeed. This ensures that the clustering results are reproducible every time I run the code. Next, I perform k-means clustering on the standardized data using k equals 3. This means the data set will be grouped into 3 clusters based on similarity. Then, I display the k-means output. This shows the clustered center and how the algorithm has grouped the observation. After that, I use the table function on km cluster to find the number of observations in each cluster. This tells me how many houses belong to cluster 1, cluster 2, cluster 3. Next, I add the cluster result into the original dataset as a new variable called cluster. This helps me identify which observation belongs to which cluster. Then, I calculate the cluster center value using the aggregate function. This gives the average value of price, bed, pet, and scale for each cluster. Next, I visualize the clustering result using FVIZ cluster. This plot shows how the homes are grouped into 3 clusters with different color and boundaries. To evaluate the quality of clustering, I use the shell-out method. This shows how well each observation fits within its assignment cluster. Finally, I interpreted the result by discovering each cluster based on the number of observations and the average value of each variable, such as price, number of beds, and square footage.
Ibu aku lebih lagi.